Hello students, today we will be studying Science Chapter 8 Static Electricity. Electric charge. Let us study electric charge by doing some activities. Take a plastic comb and rub it on your dry hair and take the plastic comb towards some pieces of paper. You will see that pieces of paper are getting attracted to the plastic comb. Next, if we pass near a polyester curtain again and again, it gets attracted towards us. Next, if we rub a blanket with our hands and take it near a metal object, a spark is seen in the dark. What do the above observations tells us? These examples are just a view of the electric charge that all objects in our surroundings hold in abundance. It means that electric charge is present in all the objects in our surrounding, and this charge is present abundantly. Electric charge is stored even in our own bodies. All substances are made of very tiny particles. Electric charge is an intrinsic property of these particles. Intrinsic means belonging naturally or essential. Though in this way, electric charge is abundantly present, it is always in a hidden state. Electric charge is present in each and every object around us, but it is in a hidden state. This is because two opposite types of charges are present in equal numbers in all these substances. In each and every object that we see around us, it has two types of charges in it, and these charges are opposite. So, if these charges are present in equal numbers, then the charge will remain in an hidden state. When the positive charge and negative charge on an object are balanced, the object is neutral, that is, there is no net charge on the object. If in an object, positive charge and negative charge are equal in number, then these charges cancel out each other or they balance each other and the object becomes neutral. If these charges are not balanced, the object is said to be charged. For example, if in an object negative charges are more than positive charge, then you can say that the object is negatively charged. Repulsion and attraction. Activity. Rub one end of a glass rod against a silk cloth. Due to the rubbing, a small charge will get transferred from one object to the other. The glass rod will become positively charged and the silk cloth will become negatively charged. As a result, both the objects will become somewhat charged. Suspend this rod freely in the air with the help of a thread. Now, charge another glass rod in the same manner and bring it near the suspended rod. What do you see? You will see that the two rods push each other away. Now, take a plastic rod, rub one of its ends against a woolen cloth. The plastic rod will become negatively charged. Bring that end near the suspended glass rod. Now, what do you see? You will see that the two rods are pulled towards each other. What did you find in the first experiment? Two rods carrying similar charges push each other away. This is called repulsion. When two objects carry same charge, they push each other away. For example, both the glass rods had positive charge. So, when they were brought towards each other, we saw that they pushed each other away. This property is called repulsion. We learn from the second experiment that rods carrying opposite types of charges get pulled towards each other. This is called attraction. When the plastic rod was rubbed against woolen cloth, it got negatively charged. So, when a negatively charged rod was brought closer to a positively charged glass rod, these objects got pulled towards each other and this is called attraction. The scientist Benjamin Franklin named the electric charges positive charge and negative charge. Origin of electric charge. All substances are made up of particles and these particles are ultimately made up of very tiny particles which are called as atoms. The substances that we see around us are all made up of very tiny particles, and these tiny particles are called as atoms. There is a stationary positive charge and a moving negative charge in an atom. Stationary positive charge means the positive charge in an atom is at rest, it does not move, whereas the negative charge which is present in an atom is continuously moving. These two charges being perfectly balanced, an atom is electrically neutral. All objects are made up of atoms, which means that they are electrically neutral. Then, how do objects become electrically charged? For some reason, the balance of electrically neutral atoms gets disturbed. Let's see how. When certain objects are rubbed against each other, the negatively charged particles on one object go to the other object. The object to which they go becomes negatively charged because of extra or excess of negatively charged particles. Similarly, the object from which the negatively charged particles go away becomes positively charged due to deficiency or lack of negatively charged particles. It means that of the two objects being rubbed, one becomes positively charged and the other becomes negatively charged. Frictional electricity. The electric charge generated by friction is called frictional electricity. When two objects are rubbed against each other, friction is produced and the charges which are generated because of this friction is called frictional electricity. This charge is produced only at the place of friction. Means the charges are produced only at that part of an object which was rubbed. Hence it is called static electricity. It remains on the object for a short duration. The charges of static electricity are absorbed in moist air. That is why these experiments should be performed in dry weather, particularly in winter. Let's do an activity. Apparatus, a few straws, woolen cloth, glass bottle. Procedure: place a straw on a bottle, take another straw near it, observe what happens and write your observations. Leave the straw on the bottle as it is. Rub the other straw against a woolen cloth and take it near the straw on the bottle. Observe what happens and record your observations. Now take two straws and rub them against woolen cloth at the same time. Keep one of the straws on the bottle and take the other near it. See what happens. Keep the rubbed straw on the bottle as it is. Take the woolen cloth on which it was rubbed close to it. In the above activity, you will observe that when a charged straw is taken near the uncharged straw, attraction occurs. Second, when two straws carry similar charge are brought near each other, repulsion will occur. Third, when a charged straw and the oppositely charged cloth which was used for rubbing are brought near each other, attraction will occur. Electrically charged objects attract uncharged objects. There is repulsion between like electric charges, means same electric charges. There is attraction between unlike electric charges or opposite electric charges. Hence, repulsion is a test used for identifying an electrically charged object. Generation of electric charge. First, to charge an object by contact. Rub a plastic comb against paper. Touch this comb with another uncharged comb. Take the other comb near some pieces of paper. What happens? When you rub the first plastic comb against paper, it gets charged. And when that first comb is brought into contact with the another or the second uncharged comb, the charges from the first comb gets transferred to the second comb and the second comb becomes charged. When this second comb, which is newly charged, is taken near some pieces of paper, the pieces of paper are seen to be attracted to the comb. Second, to charge an object by induction. Induction means to give rise to something. Rub a comb or a balloon on your hair. as shown in the picture. Take the comb near a thin trickle of water from a tap. See what happens. Now draw the comb away from the trickle and observe what happens. At first, the flow of water is not charged. When a negatively charged comb comes near the flowing water, the negatively charged particles in it nearest the comb are pushed away. When the comb is rubbed on hair or balloon, the comb becomes negatively charged, and when such negatively charged comb is brought near flowing water, the negative particles in the flowing water nearest the comb are pushed away because of repulsion. That part becomes positively charged due to a deficiency or lack of negative charge. The comb has negative and the water has positive charge. Due to the attraction between the opposite charges, the flowing water is attracted towards the comb. When the comb is taken away, the negative particles in the flowing water come back to their original position and positive and negative charges become equal in number. As a result, the water becomes uncharged again and stops getting attracted to the comb as it is away from it. Effects of electric charge. When an uncharged aluminium ball is brought near a negatively charged balloon, the following things happen. As shown in figure A, an opposite charge is generated in the other object by induction and both the objects get attracted to each other. When a negatively charged balloon is brought near an uncharged aluminium ball, an opposite charge, that is, positive charge, is generated in the aluminium ball by induction and both the objects get attracted to each other. As shown in figure B, on touching, both the objects become similarly charged. When aluminium ball and balloon are brought together or when they touch each other, negatively charged balloon transfers its negative charges to the aluminium ball and the aluminium ball also becomes negatively charged. That is, both the objects becomes similarly charged. As seen in figure C, the like charges repel each other. Gold leaf electroscope. This is a simple device to detect the electric charge on an object. It consists of a copper rod which has a metal disc at the upper end and two thin gold leaves at the other end. The rod is placed in a bottle so that the disc is above the bottle, and to prevent the loss of any charges, the device is kept or the setup is kept in a bottle. When an uncharged object is taken near the disc, the leaves remain closed. When a charged object is taken near the disc, both the leaves are charged by the same electric charge and repel each other, that is, move away from each other or open up. When a positively charged rod is taken towards the metal disc, the positive charge from the rod is transferred to the metal disc. The positive charge travels from the metal disc up to the leaves and both the leaves are charged by the same electric charge and they repel each other. When we touch the disc with our hand, the leaves collapse because the charge in the leaves goes into the earth through our body and the leaves gets discharged. Lightning and lightning strike. When air and clouds rub against each other in the sky, the upper part of some clouds on the upper side becomes positively charged and the lower side of the clouds becomes negatively charged. When air and cloud rub against each other, friction is produced, and because of this, both the clouds and air get charged. The upper part of the cloud becomes positively charged and the lower part of the cloud becomes negatively charged. When this negative charge on the bottom of the cloud becomes much larger and heavier than the charge on the ground, it starts flowing towards the ground in stages. This happens very fast in much less than a second, and heat, light and sound energy are produced along with the electric current. When there are electrically charged clouds in the sky, electricity is easily attracted towards a tall building or tree because tall building or tree are much closer to the sky than the objects which are present on the ground or surface. When lightning strikes, an opposite electric charge is generated on the roof of a building or on the top of a tree by induction. Means if the cloud has negative charge, then an opposite charge, that is positive charge, is generated on a roof of a building or on the top of a tree. Due to attraction between the opposite charges on the cloud and the building, the charge on the cloud flows towards the building, and this is called as lightning strike. Lightning conductor. The lightning conductor is a device used for protection from a lightning strike. It consists of a long copper strip with one end forked. This end is at the highest part of the building. The other end of the strip is connected to a plate of cast iron. Cast iron is a group of iron-carbon alloys with carbon content more than 2%. A pit or hole is dug in the ground. Coal and salt are filled into the pit and the iron plate is placed upright in the pit. Coal and salt are used to increase the conductivity of the soil. Coal absorbs water and keeps the soil wet, and soil is added to increase the conductivity. There is also a provision for pouring water into it. This helps to spread the electric charge quickly into the ground and prevent damage. Whenever an electrically charged cloud passes over the building, the electric charge flowing towards the building are conducted by the lightning conductor into the ground through the copper strip, and damage to the building is prevented. When such a lightning conductor earthing is fixed on a tall building, the surrounding area is also protected from lightning. So this was all about lightning conductor. I hope you all have understood the lesson. Thank you.